Hi, hello everyone. Good morning from London and welcome to our 5G workshop. Wherever you are today, thank you very much for tuning in. My name is Diana from Innovate UK Edge at University College London, and today is my absolute pleasure to be moderating this workshop. So you know that the promise of 5G has been around for many years now, and with its rollout and adoption continue to accelerate, I'm sure you'll be wondering the real value of 5G for your business and that why your business should be caring about this technology now more than ever, especially given the current climate. So my colleagues and I have assembled an expert team from both academia and industry to talk about this matter. So in a minute, I will proceed to introducing today's speaker. But first, I'd like to give the audience a little bit of encouragement because we can't see you behind the screen. So please do feel free to interact with us via Slido. You can either ask questions or simply just say hi and tell us where you're from or what industry you represent. And my colleague, Isabel, who's working behind the scenes, and myself will be facilitating the Q&A section towards the end of the workshop. So without further delay, I will now share my screen to introduce you to today's speaker. I think I'm on full screen now. So first we have Alexander Sisoev, Managing Director for Ericsson Austria. And then we have Werner Krels, Senior Vice President for Business and Wholesales from Magenta Telecom Austria. Then we have one of our own, Dr. Rob Thompson from UCL Institute of Communications and Connected Systems. And finally, last but not least, we have Associate Professor Vasos Vassiliou from Science Center of Excellence. So now I will give the stage to Alex. Now let me stop sharing.
Thank you, Diana. Hi, everyone. My name is Alexander Sisoev. I'm Managing Director and the Country Manager of Ericsson Austria. And today I have a pleasure to share some insights with you when it comes to the benefits that 5G technology is bringing to the industry. So bear with me, I hope it will be interesting. And of course, feel free to ask the questions afterwards. I would like to start with setting a bold message that we see the 5G as a tool to address various industry challenges. And on this picture, you can see sort of the 5G compass that we believe helps to orient different industries across the use cases, across the value they can get, and also across the different characteristics that they can unlock with the full support from the 5G. What we have seen as of today is that many industries have an experience of working with 5G just through the perspective of curiosity, trying to understand what 5G technology brings, and also a bit disaggregated from, let's say, all the set of the benefits that 5G can really deliver. And what we are trying to do and what we have launched in the last few years is a sort of a holistic approach where we try to consolidate the view from industry, service providers, also from inside in order to understand and unlock the full support of the 5G potential. On the right-hand side of this compass, you can see the set of the different industries that are either getting the benefits of the 5G or supposed to get the benefits of the 5G in the near future. As one could say that practically there are all industries that are well known for today, and that's actually true. We believe that all the industries are getting the benefits of the 5G. This fully depends on digitalization potential of the industry and the usage of the 5G as a tool to improve this digitalization journey. Yes, some industries are getting the benefits of the 5G a bit earlier. This is just through the perspective of, let's say, the complexity of the rollout and the digitalization maturities that these industries are. And a good example here would be probably the manufacturing, where already as of today, we see numerous benefits of the 5G technology that it brings to the various use cases. In the center of the compass, you can see the different value blocks of the 5G technology. Yes, probably the easiest and the natural way that 5G can deliver is the connectivity being unlocked and delivered through the service provider. But then the full potential of the 5G is possible to unlock once you start climbing in the value that 5G brings. You can start looking into the possibility to have service enablement. You can have a look into the possibility to develop the certain applications on top of the certain use cases. And on top, you can even look into the extra services that the service provider can bring on top of the developed applications, collected data, and delivered connectivity. And then, of course, there is a set of the different characteristics that 5G is able to deliver to the industry. Some of them are well known and coming just from the DNA of the 5G technology. Good example here would be superior performance and low latency. But there is another set of the characteristics being delivered by 5G. Either we are talking about the security by DNA, or we are talking about the potential to automate certain processes, or we are talking about the real-time collected data and process data during the same part of the operating processes. So the set of the characteristic is a bit broader than just performance and the latency. Then when it comes to the use cases that we have observed, I think the variety of the use cases is really broad. In our joint research together with Artur de Little, we tried to consolidate all the use cases into 9-10 different groups. And the usage and rollout of the use cases depends on two things. On one hand, it's a complexity of the rollout. Is it challenging? Is it easy to deliver certain use case and roll it out in, for example, manufacturing premises? And the other aspect is a digitalization maturity, meaning where the specific company in the digitalization process and how 5G can be used as a tool to improve this digitalization. What we have seen so far that there are some use cases that are much easier to roll out, or they can be considered as a sort of low-hanging fruits. Many of them are laying in the category of the monitoring and tracking. For instance, could be the tracking of some objects that are being delivered between or being commuted between the warehouses and the production centers. And some of them are relying on the maintenance sensing, meaning using sensoric in order to collect certain data during the digitalization process. Once you start moving to the right, meaning the complexity of the digitalization increase, and once you start moving to the up, meaning that maturity is also increased, you start getting more and more use cases. And of course, variety of these use cases can be really broad depending on how you use 5G as a technology. Now I'd like to combine the view on the specific industry and the view on the specific use cases. And for that reason, I'd like to invite you to have a look at the particular example. That's example coming from the smart manufacturing industry. So here you see, just as a matter of example, 5 different clusters of the use cases coming also from the previous slide, and how they can benefit the manufacturing processes. So what we have seen is that one of the aspects of the 5G is unlocking the real-time automation, and that's being used in the production processes. One example here could be a joint collaboration that we established between the car producers, service provider, and ourselves in one of the companies. And what they are doing, they are actually collecting the data, and based on the collected data in the real time, tune the production processes. And also they use automated guided vehicles to commute between the warehouse and the central production line in order to deliver the goods. That's fully automated. Another example is about the robotics. So this category is about the collaborative robotics and purely automated decisions that's being done. I think that robotics is already for years quite widely used in, let's say, manufacturing processes. What 5G can bring is additional value, is a move from the wireline connected robots to the wireless connected robots. The benefit coming from the cellular technologies. Another good example of the use case is augmented reality. It's also a use case that we use in our own production facilities. For example, in one of our factories in Estonia, in Tallinn, we're using augmented reality in order to do the real-time troubleshooting process during the production of the PCBs. Another group of the use case, monitoring and tracking, that's something that is widely used by the factories as we speak, and that's related to the tracking and the monitoring of the goods, for instance, that are used in the production processes. And enhanced video services, what we can see here as a matter of example as well, for instance, remote trainings, remote troubleshooting happening also in the real time. Those are just a few examples. I think that the potential might be even bigger. What is critical here, as you can see on the bottom of this slide, is the key thing is to know what processes are possible to digitalize, how the legacy processes work in the industry. Without having this knowledge and without working on this subject, it would be hard, of course, to bring the extra value of the 5G. Now, probably concluding my part, I would like to convey one simple message that 5G is much more than just speed and latency. Yes, by the DNA of the technology, by the architecture of the mobile technology, 5G is supposed to bring, and it actually bring in superior speed and the low latency. But there are a few other aspects that needs to be considered here. One is that 5G gives you more, the more tasks you give to the 5G. We have seen it at an example of the manufacturing, and that's a sort of prerequisite for digitalization. Another thing is that you need to know the processes that exist on the industry side and what processes could be digitalized and work more effectively, because at the end of the day, industry is just willing to have reliable processes that save the money and open the new streams. And one more aspect that I'd like to stress explicitly is ecosystem approach. 5G brings you more value once you collaborate with other actors, and those actors are service providers, academia, universities, research entities, and also probably vendors of sensoric or some other devices that are being used in particular use cases. This ecosystem approach is extremely important, and as I said, we saw in many use cases and many actual projects that the value of 5G is just being boomed once you start collaborate with different actors. Having said this, I think that I'm done, and thanks for your attention.
Thank you, Alex. Thank you. A very clear message there about 5G use cases for multiple sectors, and I agree with you. In order to bring real value of 5G, it needs to be collaborative in nature. So now I hand over the stage to Werner, who will give us the perspective from the supplier point of view.
So also a very warm welcome from my side. I would like to give you my perspective from a telco operator, from a supplier. Just a short overview about Magenta Telekom. We are part of Deutsche Telekom Group, located here in Austria. The company size is 1.3 billion euros of revenue, 0.5 billion EBITDA. We have approximately 5 million mobile SIMs in the field and about 635K fixed access points here in Austria. We invest roughly 270 million CapEx invest every year. Most of that goes into our networks, part of it also in our IT systems. Our portfolio is mobile, broadband, internet, voice. We also offer TV and entertainment services and ICT solutions. So coming to the topic about what 5G actually means in terms of access technology, we are providing all these technologies right now as access technologies to our customers. So of course, fiber. Then we also have a cable network in the larger cities of Austria, which is based on HFC technology, which stands for hybrid fiber coax. And we also have a legacy technology, which we actually do via whole by, which is DSL related and DSL based. And of course, now we are very much focusing on rolling out 5G. We have acquired licenses for 5G in different spectrums. One in a high frequency spectrum of 3.7 gigahertz. And also we have acquired a lower frequency band in 700 megahertz. We are also we are what we call refarming frequencies that we have acquired in previous periods, mainly for LTE, but also for UMTS many years ago. And we are refarming frequencies and basically apply 5G technology on that frequency, on these legacy frequencies. What is important to understand is that 5G is really a massive technology uplift, mainly because of the protocol, but also because of the frequencies that we are using. 5G will provide speeds up to 2 to 5 gigabit per second. Currently in our cable network in the HFC technology, we can already provide up to 1 gigabit per second. But 5G will go further ahead. And this is, and also what already Alexander has explained, 5G can also provide massive connectivity. So many SIM cards connected in an area, in a specific area, and is also able to provide low latency. However, it's also important to understand that, of course, the laws of nature still apply, which means that the higher the frequency is, of course, the shorter the wavelength is. That provides an option of so-called MIMO, which stands for massive input, massive output antennas, which means that you can basically build in a couple of antennas within one base station. And it goes up to 64 times 64 antennas in one base station, which of course then provides higher bandwidth. However, the higher the frequency is, also the lower the radio range is. And also the higher the frequency is, the lower the radio indoor and in-house penetration gets. And on the lower frequencies, and it's still high frequency, but still lower than in the gigahertz range, at 700 and 800 megahertz, for example, the frequency is, the bandwidth is lower because massive input, massive output antennas are limited simply because of size, because the wavelength is longer. But you also have a higher radio range, and you have higher radio indoor and in-house penetration. That means for us as an operator, we basically have to balance these technologies in order to make sure that we cover the right spots of Austria, here in Austria, and to connect businesses. So fiber mainly for SMEs and LE, cable networks within the cities for VSE and SE customers, and 5G basically for rural areas where you won't be able to dig in a fiber cable to each value and each municipality of Austria. So 5G will provide broadband access to everybody, to all consumers, but also to all business wherever they might be in a country. This is already the first big benefit of 5G. The second big benefit of 5G is about what we call campus networks. So today there's a public radio access network, which basically everybody can use who enters a specific areas or a range of a base station. What we do with campus networks is basically to put a private slice into the network that enables specific access only to a company or access to specific use cases of a company. So here's an overview of what we are doing here. Of course, you can basically provide specific base stations in order to have access and provide good service to a specific area, but still it would be public. The second one is where you basically put a virtual private slice into the radio network access network. And the last one is basically where all the benefits are then coming in, which is to provide a real private slice, not only virtual private slice. And on this campus network advanced, we also put in a so-called edge core, where you basically divert the traffic directly into the backend core of the customer without going through the public internet. And then if you do that, basically you have all the benefits and all the features here, which is enhanced indoor coverage because you basically put a base station directly for your business or your manufacturing unit or whatever site you want to cover with it. It's a managed network, so you don't need to care about the network management. You have very high data security. Alexandra has already mentioned that. A high quality of service, high speed, a guaranteed bandwidth, a high reliability. And if you use the edge core, also ultra low latency. And you can really do edge computing technologies in order to provide use cases. So all in all, that means that if you provide such a campus network in all the flavors that we have just seen, it's all about this massive connectivity. That would mean that you connect many devices to the network. You can also do various products and to make sure that their production line is end-to-end monitored and optimized. You can do a flexible reconfiguration of your product lines because it's not wired. So basically, you have much more flexibility because it's a wireless access technology. Real-time remote monitoring, also very important, and specifically an end-to-end monitoring across the whole value chain. Predictive maintenance, there are lots of use cases already out and lots of good examples how this is used. Automated guided vehicles, we are doing that, for example, in a smart factory together. Alexander, so Ericsson and us, Magenta, we are supporting a smart factory of the Technical University of Graz here in Austria, where they also do some testing about these automated guided vehicles. Automated loading processes, augmented reality for repairs, maintenance, and operations. That's also something that is currently tested in this laboratory smart factory of the Technical University of Graz. So after all, 5G is really a massive evolution and revolution at the same time of access technology. Evolution in the sense that it will provide broadband access to every household and to every business in the country, wherever the business or the household might be. And second, it also provides, with this campus network capability, really innovative use cases. And I fully agree with Alexander, as he said, to exploit the value of 5G. Basically, it's important to partner, and it's also important to understand what processes and production in this regard, Industry 4.0 processes and options you want to tackle and you want to improve. So that's a short update from my side, from the operator supplier side. Thanks a lot.
Thank you, Werner. That's a very nice, comprehensive overview. May I just update for the audience, please could you refresh your Slido and so that you can continue asking questions. Now we have something very different from Dr. Rob Thompson, who's going to give a perspective from academia and industry collaboration side of update. Rob.
Great, thank you very much, Diana. Yeah, I think that what I'll be reflecting on here is kind of what Alexander brought up, which is as the complexity increases, 5G is where really 5G starts to benefit, and the ecosystem. And I think when you start bringing in multiple actors and you increase the complexity of the questions you're answering increases as well. And that's really where I believe academia and industry can work well, where we get these boundaries and where these complex questions come up. I'm from UCL, so I'm just starting my timer to make sure I don't run over. I'm from UCL. UCL is one of the top 10 universities in the world by the QS rankings, an extremely multidisciplinary university, which I think brings in advantages when we're talking about 5G. Within UCL, I manage an institute called the Institute of Communications and Connected Systems. We're about 120 researchers that work over both fundamental and applied technologies for connected systems. And quite uniquely, we are a research group that spans communication technologies. So we have world-leading optical communications experts, world-leading wireless communication experts, and then world leaders in technologies that we look to integrate across those mediums. So machine learning, AI, the combination of communications and radar technologies. We bring all that together and really try and collaborate across the technology area. And then we collaborate with global sector leaders internationally and startups and SMEs, hopefully like the audience that we've got here today. And through our educational side, we're creating communications and engineering leaders of the future. If we kind of step back and look at UCL more broadly, UCL is extremely multidisciplinary with leading schools in arts, medicine, economics, teaching. And really what we're able to do based there is bring all this expertise in, which gives us a huge ability to explore application domains for communications technology and bring in the experts there. So why is 5G really a space that you can explore for industry and academia collaborations? I think if you look at the early stages, we've got the core fundamental researchers who are looking at that TRL, low TRL, technology readiness level research and exploring the technologies that can create paradigm shifts in communication technologies. Looking at how they integrate within 5G, looking at how they potentially as well, I mean, we're looking now at spectrally efficient waveforms that may be integrated into later versions of 5G or looking forward into 6G. And these can really make the paradigm shifts, but you need the academics who are looking in a completely different direction and aren't having to follow industry trends to create those paradigm shifts. So I think that's one place, but we're perhaps progressing past there now with 5G. The next place that academia starts to come in is if we look at 5G and how it's developed, 4G, and also as we look towards 6G, we see that the operators and the over-top players are starting to blur, and we're creating, as Alexander mentioned, this complex ecosystem of actors. And I think if you want to explore the true value of 5G, we've got these dispersed applications and we need to stop looking at them with a traditional lens. So once you bring in this complexity, once you stop looking at things with a traditional lens, you start having to ask some unusual questions, some different questions, and maybe actually the skill is working out which questions you should be asking. And that's really where academics excel. You know, that they're not bound by the drive for a product or a profit, and therefore they can think in a very cross-sectoral way if they wish to, and deep dive along with industry. So I think what works well is when industry sets the boundary conditions that an academic has to explore within, and then an academic can bring some of that fundamental or that wide-spanning research and see how it applies within the constraints that are put upon them. I think another area that makes academia a great player for a collaboration here is that it has an opportunity to act as an aggregator. We don't have a commercial drive, and therefore we can bring in many different players to explore the kind of the fuzzy spaces where questions lie at boundaries, and we can bring in multiple disciplines. The next thing I'd like to talk about is just a reflection on some demonstrators that happened are happening in the UK, led by the Department for Culture, Media and Sport, Digital Culture, Media and Sport here in the UK. And UCL led the technology input to a recent review on there. I'm not going to go into specific projects, but just some overview takeaways that either allowed these projects to flourish or not flourish as much. And I think they maybe inform how you can go about the sort of demonstrators and the sort of projects where academia and industry tend to collaborate. I think the first takeaway point that we found was that you really need to identify the true value of the new technology and what is the new ability that creates and what are the unique opportunities. If we want our operators to really have a business case that allows them to drive 5G rollout, they need to have applications that can't be done on 4G, that can't be done on wireless. And therefore, if you create an all singing, all dancing demonstrator that's brilliant, uses 5G, but could work on other communication platforms, then I don't think that that's going to be the best. If we then move forward, I think showing the economic impact of the collaboration you're doing requires not just technical expertise, but needs robust economic and impact measurements and expertise. Failure doesn't mean failure, especially when you're exploring a new technology. If you've got a great group of people together and your project is not succeeding in a technology direction you were hoping, pivot, I believe, is the right thing to do. Use your expertise and see how you can show the benefit of that group of people, of the infrastructure, to perhaps provide something which wasn't your initial goal. And finally, while being ambitious, I think you need to be clear on the onset of what's realistically provided by different partners. Often collaborations fail because we're not sure who is actually providing the unique advancement. So I'll quickly now, before I run out of time, just reflect on the methods of engagement that you can have with a university. And these really range from the very short-term student engagements to the long-term strategic collaborations. And these are most successful when engagements provide a tangible advancement, both to the company, but also to the academics' career trajectory and an academic drive. They would love to help every company that comes to speak to them, but they want to see an academic question or benefit that allows them to develop their practice. And I think that's sometimes lost. And when we think about what those benefits are, for industry, it can be exposure to top talent, de-risking their innovation, exposure to diverse opinions and thoughts. There are many benefits, including branding and and access to thought leadership by associating yourself with top tier universities. And for the academic collaborator, I think it's worth, as an industry member, bearing this in mind when you enter the discussions, but exploring diverse application spaces is what the academic wants to do, creating a tangible impact on the world, but also increasing the benefit and prominence of their research and exploring new academic challenges which help them to come up with new ways of questioning what they do. The final thing that I think I will leave is that a note of caution is that your academic collaborator or your industry collaborator is not going to know more about your problem than you are. You've invested in the problem and have explored it. Often I sit in these meetings and people assume the solution will come out in an hour's meeting. And really that's very unlikely. So expecting the academic collaborator or the industry collaborator in the other way to know your problem better than you do, I think is the wrong way of entering a discussion, and often that happens. So I think my takeaway message would be exploring collaborations in a multidisciplinary space between industry and universities is an excellent way to propel 5G innovation. Thank you.
Thank you. Thank you, Rob. Very, very nice. So the key takeaway I got is the collaboration needs to be mutually beneficial for both sides, obviously. So can they, if they want to speak with your department, can I get in touch with you directly, or?
Yes, yeah. So if you just find the institute on the website, the Institute of Communications and Connected Systems, ICCCS at UCL, just Google that, you'll find our web pages, and there's details in there on how you can contact me directly, and all our academics are listed there if you have a specific research interest.
Great, fantastic. Thank you, Rob. Now, last but not least, we have Associate Professor Vasos Vasiliou, who's going to give you an update on the latest 5G research from a pure academic point of view.
Thank you, Diana. Well, I'm going to try and kind of combine a few things that we've seen before and show the vision that can be incorporated into new solutions coming from SMEs mainly. My affiliation is mainly the University of Cyprus, where I'm the co-director of the Networks Research Lab, but I'm also part of the newly formed Science Center of Excellence in Cyprus. I'm going to talk a bit about that. So my research is mainly telecommunications and protocols, and lately 5G, 6G, and the Internet of Things. Science is focusing on interactive media, smart systems, and emerging technologies. It's a collaboration of all the public universities in Cyprus with UCL and the Max Planck Institutes in Germany. And this allows us to bring fundamental, let's say, and applied academic research, but then move out and strive for industrial innovation so that we grow the economy of Cyprus first, and then the region and Europe in general. What we have now is a very diverse group of people, kind of combining their expertise in what we call multidisciplinary research groups. And you see here 16 of these groups. My group is the Smart Network Systems group, and it's the only one doing this type of research in communications. Others are doing a lot in interactive media, VR, AR, image processing, computer vision, graphics, and then we have a lot of people in AI and machine learning. I'm going to talk about 4, let's say, possibilities in extending 5G or using things that happen already. And for those who are not very familiar with 5G, we usually describe 5G as having providing a triangle of services. The top one of them is enhanced mobile broadband, and there the focus is on speed, like it was explained by my predecessors. Then there is the ultra reliable and low latency parts, where you see 1 milliseconds latencies and very low error rates. This is something that you would like in a smart manufacturing examples like the one Alexander gave us. And then we have massive machine type communication, things that relate to smart homes and smart factories and smart cities, in which speed and delay are important, but it's also important to manage a large number of devices. Let's see first something from the enhanced mobile broadband vision. 5G is actually spearheading a very interesting standardization effort in defining specs and application profiles for virtual reality, augmented reality, and mixed reality. Combined, we call these extended reality. And these types of realities, let's say, can be found in cloud gaming, in mobile esports, or I don't know, AI, storytelling, even Hollywood productions. So there is an inherent drive in 5G to help all these applications. So anyone interested in getting in this field business-wise, they don't have to create all the details. A lot of people have actually worked on defining these things. Now, we are very interested at Science about immersive applications and tactile applications, things that relate to people and their interaction with the machines and the cyber world. And there we can recognize that things have to go down to the edge. There was a question before about examples of edge computing. This is why edge computing is needed, because if you're processing things that need, let's say, sensing or motion capturing, and then feeding back this into something, haptic glove or something like that, you need to reduce the communication between the two edges, the server and the client. And 5G is very much doing that. Of course, there are a lot of challenges to make this happen. Challenges that have to do with the way we perceive things visually. So displays have to be better. The scenes, the environment that we see, the made environment, the 3D objects, the assets have to blend well with the actual environment. And then you have to deal with the more technical issues like energy consumption, battery powers, thermal dissipation. And then is also the other practicality of recognizing, doing eye tracking or hand motion tracking and stuff like that. So these are open issues that are very much useful for a new company to get into. Another, let's say, a bit more sexy and maybe more into the far future rather than the immediate future is the use of hypersurfaces. This is something that we were part of as in a European project called Visor Surf. These are surfaces who have the ability to change their electromagnetic behavior, either for absorbing certain frequencies or reflecting certain frequencies or changing the angle of reflection, so that you can either provide better quality of service or security or minimize interference or even do wireless power transfer. There is a drive nowadays for reducing the reliance on fixed types of batteries. And over here, we can find applications in many areas. And the last item I would like to point out that it holds, let's say, potential to be explored is something that is also included in 5G since release 16, which is about extending the natural cell tower smartphone device reliance, and then use user equipment or smartphones as relays, either single hub or multi-hub, or for the extension of coverage, or for better quality of service, or for serving the same content to a group of people who happen to be near each other. So all these can be utilized for unique new types of applications, like local services, applications based on social or contexts, or emergency communication, IoT enhancement, the smart factory stuff that we've seen before, and even indoor positioning. So as a key takeaway, I would say that 5G and 6G applications will probably rely more on what I call mass personalization. That is the ability of the system to provide specialized services to everybody on scale. To do that, we need AI and machine learning, both for the network and the applications. And we need to incorporate that in unique solutions. But to do that, the operators, the service providers, the integrators, and the developers need to kind of have a focus on humans. It seems that humans will be playing a key role in the advancement of these applications. And this is where science is able to help, because we do have a human-centric approach to our research. We are tackling problems in a holistic way. I've shown the type of disciplines that we have, and then we can help with what Rob was suggesting, these collaborations for between academia and industry, so that we can bring out more system solutions. I'm going to skip our initial results. We have a lot of ideas and collaborations giving out all these things. You can contact us at science.org.cy to find out more about the whole spectrum of our work, or you can contact me directly if you have any specific question. Thank you very much.
Thank you, Vassos, for your insights. Now, because we only have 7 minutes left for the workshop, I would like to go straight to the Q&A section. So one question I have here is that you mentioned that edge computing can help create use cases. Can you give some example here? So perhaps the speakers can also couple it with some of your final thoughts on the role that 5G can play in a post-pandemic world, I suppose. Final thoughts. Anyone want to take it over?
I can start if I may. Like I said, a lot of immersive applications and a lot of low latency applications require the push of computation towards the end user. So we move from the big data centers that we've had so far towards something that can be done much closer to the user. That can be the base station, or can be a gateway in a home or a factory, or even the phone itself, device itself. Now, I would say that especially in the post-COVID world, we see that people have changed their entertainment preferences. We have more streaming, we have more online games, and these, as we go along and we add the extended reality applications that I have mentioned, have a better or a bigger reliance on this, on edge computing. That's my thoughts on this.
Maybe I can add here a couple of comments, fully echoing what Vassos has said, and I think that Werner, during his presentation, made a clear statement about edge computing as well. I think that it's mobile operators are in a perfect position to route the traffic towards optimal location where the enterprise or particular industry is hosted, and the benefits could be realized in several steps. Yes, today it allows to consider on-premises deployment, but tomorrow, for instance, it can open up an opportunity to have commitments towards certain more challenging SLAs because you have already presence in a particular location, and in future this can even help to blur the border between the devices, applications, and specific use cases. This is where we see the benefit of the edge.
I guess from our point of view, I think moving compute to the edge raises lots of other questions and benefits that can happen. For example, privacy. If you've got compute on your device, suddenly your device can deal with information and ensure that data is being sent from the device, but anything that's private is kept on the device. So you can create new services now that deal with private data and give out information for a service, but is kept on the device, so kept private, the bits of the information that you want to keep private. So I think that's just one example of where edge computing doesn't just impact how you can deliver a service, but allows you to deliver new services that perhaps wouldn't previously have been able. And I think by exploring these ideas, we're going to come up with new opportunities as well as ways of making current problems, finding the solutions to current problems as well.
Maybe to add from my side, what we see is that today, edge computing is already important wherever it requires very low latency. That might be in an industry context, autonomous vehicles, for example, or might be in a consumer context, gaming, just as two examples.
Thank you. I think we have one last minute question about Magenta's strategy of providing 5G, but Werner, if you're able to give an answer in 2 minutes, if that's okay. So the question is, the advantage of 5G, like higher data rates and lower pings, are not reachable with the often used 5G DSS. What's the strategy of Magenta to provide real 5G in 2 minutes?
Well, that's in 2 minutes.
I know,
but
it's
I would
impossible.
say mainly, the 5G, it's a matter of commercials, of course, because as I said, we have different network technologies at hand. We can provide and dig fiber to the country. We have the HFC, the hybrid cable network, and we have mobile. And of course, we need to find a commercially reasonable balance of all of that. However, when it comes to mobile, sooner or later, 5G will be the technology covering the whole country. We're already going there. We have the frequencies, and we, as I said, we also refarming existing frequencies towards 5G. So what does real 5G mean? This is the question. Yeah, it's on the parenthesis I saw in the question. Real 5G is, of course, everything which is provided by 5G protocol from a technical point of view. But I assume that whoever raised the question means real 5G in a sense of providing all the benefits that I basically listed in this, what we call Campus Network Advanced solution, which is basically using the very high frequencies and using an edge core at the same time. And everything it's in between is also still 5G. So I think it really depends on the specific use case, what is really required, because not every use case requires real 5G in a sense that everything from low latency, highest possible bandwidth, up to security, edge core, in order to have low latency is really needed. So I hope it's that's the best answer I can give. But we will provide 5G, real 5G, in a sense of 5G protocol to the whole country and to the industries and the sites basically that will need it for further enhanced use cases in a campus network context. That should be the short answer.
Great, thank you very much, Werner. And with that, we are at 10:20. I need to close off this workshop. I just want to thank all the speakers. Thank you very much for all your hard work and effort in the past 4 months, forming this workshop together. And thank you very much for the audience for joining us today. I hope you enjoy the rest of your Software Days 2021. And take care. Stay safe.
Thank you. Bye-bye.
Bye.
Bye-bye.
Thank you.